Hey everybody, welcome back to Madland. Check that out. So we know we know about the cats, right? So the cats, you throw a cat up in the air, right, or he falls out of a tree, and how does the cat always land? Oh, he's always on his feet. Yeah. So we want to, we dig science. Science. Hey, let's have an experiment. Let's see what happens with the rhinos. Testing whether or not rhinos land on their feet. Yes. Science. Let's get to work. Okay, hoping you enjoy this here today. We've gone full HD because that's just what I need to do today. Hopefully it's not too big of a hassle for you. Probably turn out to be very pleasant if I can manage to keep all what I'm doing on the screen, so that'd be cool. We'll see how it goes. But anyways, page 838, honors or not, I hope you're all tuning in and checking those solutions. We'll talk about this stuff first, and then you took a quiz, didn't you?
I have
Isn't that right? Yeah. Took a quiz, so we'll talk about this, go over questions from this, then we'll go over questions from a quiz, and then we're gonna dismiss those folks that are not honors, and you all may proceed. You all may proceed to the next section. Okay. Okay. So questions from Mr. Elijah Scroot. Where do you want to start, big guy? Fine little review assignment, wasn't it? That's great. Page 838. Did lesson 5, 6.
Number 15 of 5, 7.
Oh no.
This one was the big bad one.
Oh no.
This one's
Not that one. 5, 7, number 15. This was the 8 to the negative 2/3. Alright, so we're in 5-7. Number 15. See if we can keep ourselves on screen. I'll do my best. My screen is very wide, but very shallow here. Alright, so we got 8 to the negative 2/3. 8 to the negative 2/3. And that's times 64 to the 1/6. Times 64 to the 1/6. Any thoughts as to how you wanted to begin?
I thought maybe turn that 64 into a 2/8.
Yeah, 2 to the 8. That's very good. We'll do the same thing here. We're going to take this 8 to the negative 2/3. We're going to turn that into 2 to the 3rd. So that's 2 to the 3rd raised to the negative 2/3. And yeah, 64. You said that's 2 to the 8th.
No,
2 to the 5th, right? Just 4 times 4 is 16. 16 times
actually
2.
what I did first was I did
Be
the
6, right?
eighths.
Eighths. What's eighths? What?
Turn it into 2/8.
2/8. What? I'm confused.
8 times 8.
Oh, you did 8 squared. Oh, well, why don't we break them down so they got the same basis? Okay, 64 is the same thing as 2 to the 6th. So 2 to the 6th raised to the 1/6. Okay, now watch some stuff clean up, and break them down to the smallest base possible. Right over here. Boom, boom. You just got 2. Okay, over here. Boom, boom. Right. The rule here is multiplication, power over power. Just multiply those exponents. So 3 times the negative 2/3. Those cancel. Right, and then I'll take you a step further. Negative exponents means just drop that to the bottom. Get to the bottom of a fraction. So that 2 to the negative 2 now becomes 2 to the positive 2. And on the top we have 2 to the positive 1. Oh, okay. It looks like there's more 2's on the bottom, right?
So 1
Yeah.
over 2.
Yeah. Here the rule of subtract. So 2 subtract 1 is 1. Right? This is gone. Just leaves a 1 up here. So we have 1 over 2 to the 1st. 1/2. Sweet. That was easy, wasn't it? But yeah, you kind of had to think to break this stuff down to the smallest base you could. Next question.
31.
31. Looks like a Jim Dandy indeed. See what we can do with that guy. So we begin with v to the 11/7. V to the 11/7. Subtract v to the 4/7. V to the 4/7, and this is all over v to the 4/7. Ooh, that is indeed icky, isn't it? I'm not even sure which way I want to go. Man, oh man. Okay, so we know that you can't have, this is v to the 4/7, right? This is like radical 7. Agreed? So let me just rewrite this. This is just so we can think here, right? This is the same thing as the 7th root of v to the 4.
You just need 3 more.
Okay, see that? So that's a problem. And that's not, we can't have radicals in the denominator.
Times 3 to the 7.
So yeah, if you stuck another 3 more of these in there, so if we multiply top and bottom by v to the 3/7, well that's gonna,
That's what I did.
oh good. That'll take care of that, because clearly that's a problem. So now let's proceed forward. Let's go ahead and take this v to the 3/7 and let's multiply it through to this guy. Alright, so what's the rule? V to the 11/7 times v to the 3/7. If you ever forget, just, backtrack. Do something simple like v to the 3rd times v squared. What is that? What's v to the 3rd times v squared?
Let's just read it.
Yeah, the rule is add. Add the exponents. So we're going to multiply, even though it's multiplication, the rule is you'll add the exponents. Okay, so v to the 11/7 times v to the 3/7. Let's add the exponents. 11/7 plus 3/7. That'd be 14/7. 14/7. Hey, I recognize that. That's just 2. Minus v to the 4 to the 7s. V to the 4/7, v to the 3/7. Add them together. 4/7 and 3/7. That's 7/7. Ooh, yeah. I'm liking that.
Yeah, I got that.
V to the 4/7 times v to the 3/7. That's v to the 7/7 again, or just v, right? So I think I'm staring at a v squared minus v.
Yeah, I got that.
Oh, okay. Well, then wouldn't you want to factor out a v? Factor out a v, that leave you with a v minus 1 all over v. I think I would just go ahead and cancel those v's right there. So are you saying that you were just like one simple factoring step away from the answer?
Yeah.
Oh, you were so close. Hey, good job, man. You were so close. You almost had it. Yeah, look at that. How about that? Yeah, you just had to factor out that GCF. Oh, the kids always forget about the GCF. Don't they? I bet if that showed up as a v squared minus 9, you would have factored it. That's v minus 3, v plus 3, wouldn't you? But since it showed a v squared minus v, for whatever reason, our brains don't allow us to recognize a GCF. Ah, that's aggravating. Any other questions from that review assignment, sir? All right, folks, we're going to have a look at that quiz. All right, so quiz 8-1. Elijah didn't have any mistakes, so that's most unfortunate for all of you. So here's, let's see, I'll put it right about there. That way you can view numbers 1 and 2. Elijah did have an awesome error. One of my favorite errors, right there. Oh, there's supposed to be an exponent there. He forgot to put his squared. Whoopsie daisy. Yeah, that's kind of bad because you're no longer quadratic.
I forgot.
Oh! Alright, so there's work. Check it out. If you're having problems, you can always get to that go-to guy. That would be a good idea, but Elijah didn't have any problems, so we're just going to proceed. Get to the go-to guy. There's 1 and 2. Let's look at, how about 3 and 4? Got 3 and 4 on your screen. Pause that video. Check those out. Maybe the work that I've shown helps you. If it doesn't, I'm sorry. I tried. And in 3, 2, 1, sliding up for the rest of the way. And there you go. There's number 5 and your bonus question. Carson City, Nevada. That's the one. Not Las Vegas. Gee whiz, that's Sin City. Don't go there, man. Don't go there.
I didn't put Las Vegas in there.
No, Elijah did not. Okay, but a lot of people would because that's the only city people know that even exist in Nevada, right? It's the only city there. People go there to do some good sinning. All right, folks, pause it, check it out, take care of it, talk to your go-to guy. And we're fixing to proceed, so here's the trick. If you're in a regular section of Algebra 1, okay, that means get off this video, and go to, I think it's 2 videos away.
Algebra 1.
Did I say, what?
You said Algebra 1. If you're in a normal section.
If you are in a regular section of Algebra 2, not 1, this is Algebra 2. If you're in a regular section, you basically just need to move on to section 8-6. 8-4 and 8-5. you get to opt out of those. 8.4 and 8.5 are reserved for the honors sections. All right, so go to lesson 8.6. That's the one you want. Okay? Okay, and honors folks, here we go. Oh, and hey, if you're just interested and you're a regular student, you're welcome to just stick around and watch. You're not required to do the homework assignment and do all that, but I think it's a really interesting lesson, so check it out if you'd like. Otherwise, just get to the next one. 8-6 is where you're going. All right, honors, let's do it. Let's talk to Eli. So we have the sun and we have the earth, and there's these two concepts, geocentrism versus heliocentrism. Yeah? Yeah. All right, so the current model accepted in science today is what, Elijah?
It's
Heliocentrism. Okay, it is believed by most scientists that the sun sits at the center of our solar system. Sun sits in the middle, and everything is revolving around the sun. Long, long ago, you had the great thinkers, Plato and Aristotle and Ptolemy. They bought into another idea. What was that? Geocentrism. They believed that the Earth was at the center and everything else was spinning around the Earth. And they had models that were pretty darn good. They did have problems, but they were able to accurately predict a lot of stuff. Okay, but there were issues. There were some issues.
Actually, theirs was just as accurate as the original heliocentrism ideas.
So theirs were just as accurate as the first. So the first guy on the scene to come up with heliocentrism was who? Test his memory. Test your memory. Maybe
they
you
claim that it's.
If you're a student here at St. Bosco's, then you've read it in your 9th grade physical science class, and that guy was Copernicus. Okay?
They claim Copernicus, but I think he actually got his ideas from somebody else.
Ptolemy. Yeah, he actually did. He did steal some stuff from Ptolemy, but Copernicus essentially was is the one given a lot of credit for putting the sun at the center, and then everything is revolving around the sun. So
But he was wrong because he didn't use ellipses. He used circles.
He used circles, and in order to deal with the problems, there were some serious issues. What he had to do is, so he puts that sun in the center.
This was actually great.
Look what he had to do. So the Earth is going around, and what he had to do is he had to do this. Woo! He had to do these little. He had to introduce what they called epicycles. Woo! In order to fix his errors. He had to put 48 of these bad boys in there. Woo! There you go. Now it works. So 48 epicycles. Again, that was also something he stole that from Ptolemy.
Originally, the geocentrism was actually more accurate than that one.
So there you go. That's what Elijah says, and I'm not going to argue the point. My expertise is mathematics. But we have some math popping up today, which is connected to this. Well, after Copernicus did his thing, another guy came along whose name was
Isaac Newton.
Isaac Newton did a lot of great work on this, but it was Kepler in the 1500s who introduced an elliptical model. So Copernicus, he was going with perfect circles, but it was Kepler that introduced a model of heliocentrism where
I don't believe in this.
Elijah renounces heliocentrism. I watched some stuff yesterday that tells me, yeah, I'm not sure I buy it. I really, yeah.
It's still theories.
It's these are all interesting theories, interesting things to think about. But anyways, the point is that Kepler introduced a heliocentric theory where instead of using perfect circles, they used ellipses. Okay, so hopefully we all remember what ellipses are. They're basically like squished circles, right? Like this guy, squished circle. All right. So if you're interested in looking at the science on this, I'm going to recommend something to you. Okay, there's some really great stuff out there. Last night, the one I watched came from the Fatima Center, and you can find it on YouTube. It's called it was only a half-hour video that I watched. Geocentrism, Crackpot Theory. Crackpot Theory, question mark. Okay, so you can find that out there on YouTube. Geocentrism, that's a G, sorry. Crackpot Theory, that's on YouTube. And then the other one, a great movie. It doesn't. This movie doesn't necessarily get into the too deep into geocentrism, but it's kind of it's kind of a necessary notion to get the whole ball rolling and help you understand how the geocentrism model really actually can work and be very accurate, right?
And be more accurate.
And maybe even more accurate, right? More accurate than what we got. So, anyways, scientists, they're always trying to modify their theories. Right now, I think folks are pretty entrenched on the heliocentric theory because the idea is, if you can get the Earth out of the center of the universe, out of the center of the soul, then really we're nothing important, nothing special. Okay. So, anyways, that's where they're going with all that. But the accepted model, as of today, is the Earth is revolving around the sun in an elliptical path. All right, so today we begin a study of ellipses. And so we're going to look at the math behind some of that stuff. Way cool. Check this. Okay, so we're on lesson 8-4. Lesson 8-4. We're going to be talking about ellipses. And so we want to give you that definition of what an ellipse is. Okay, how do they define it in mathematics? You can find the same definition I'm going to write in your textbook. Okay, so an ellipse, simply the set of all points in a plane. That's not an airplane, folks. What are we talking about? A what? A plane, flat surface, right? Like a table, a flat surface, right? That extends forever and ever in all directions. So a set of all points in a plane such that the sum, we know what sum means, right? Answer to an addition problem. The sum of the distances from two fixed points is constant. And then we say, what? I'm not sure I follow your definition. Let me demonstrate it for you. Look at this. Okay, check out my cool little cardboard ellipse. Do you like it? Do you love it? Man, I love it. This thing's great. So, here's what we do. Talking about two fixed points. Fixed point 1, fixed point 2. They actually have names. This is a point called a focus. That's another point called the focus. Have you ever heard the word focus before? Ooh. Neighbor's dog, our dog, having fun together. Isn't that great? Cool, they're like buddies. Roof, roof, roof. They must have saw a leaf fall out there or something. Alright, so have you heard the word focus before? Say yes.
Yes.
Oh yeah, we talked about focus, but that's connected to parabolas, right? A parabola has one focus. Ellipses have two foci. Two foci, or foci if you'd like, but that's the plural form. I prefer the soft C, as we would do in Latin, foci. And yeah, so there's those two fixed points, and the definition said, so it's the set of all points in a plane, all of these points that are on my cardboard plane, each of these is a point on that plane, such that the sum of the distances from two fixed points, here's my fixed points, the sum of those distances, from two fixed points is constant. Right, so here is a point, a point on that plane, that's on the ellipse, and the sum of the distances is represented by this black piece of yarn. Watch what happens when I move to a different point. You'll notice that that black piece of yarn is maintaining the length of this piece of yarn is not going to change. All right, it's anchored in right there, and you'll notice I can just trace along this path of the ellipse, and it never changes. So as I trace along there, the sum of those distances is constant. Ooh, I think I broke my pencil. Alright, that's it. We can do the same thing on the top side if you want to, but same demonstration. The sum of the distances, think I'm sorry. Mea culpa. All right, so the sum of those distances is constant. Okay, any point on that plane or on that ellipse that you go to, okay, the distance from here to here, distance from here to here, you add them up, and it's a constant. That's really nifty, really cool. Wow, cool. And this is actually how I, in fact, really truly made this ellipse when I made it originally the first time, a long time ago, is I put that piece of string on there, had my two foci, and traced, and it gave me this very beautiful, perfect looking ellipse. So there are parts of an ellipse that we need to be familiar with, okay? We're familiar with axes of symmetry on parabolas. Well, these have two lines of symmetry that cut it in half. And the long one, I hope it makes sense to you, that the long axis would be called the major axis, and the shorter one would be called the minor axis. Okay? Make sense? Circles have centers. Well, so do ellipses. Ellipses just like a circle that got squished, right? So we have a center point, all right? In addition, these guys at the end of the major axis, those are called the vertices, okay? So you actually have two vertexes. Those are called vertices, all right? Now, to make all the math happen, we need to talk about a few numbers, and we're going to represent those with some variables, all right? The first one is the distance from the center to a vertex, from a center to a vertex. This one's currently positioned, the center being at the origin, 0, 0. So from here out to this vertex, A0, what is that distance then? From here to here is how many units? It's A units, okay? And I've made a note of that with this little guy right here, all right? So this entire length from here to here is A units, all right? That is a standard. This is going to be connected to our equation that we write down here in a minute. From the center to a vertex is A. This is along, always along, the major axis. Okay, along the minor axis, we'll go with the next letter of the alphabet, and that distance will be B. Okay, so to get to one of those endpoints along your minor axis, travel B units. B units up and B units down, and there you go. Okay, well, there's also another number that's very important. So just like we used the number or the letter C to represent on parabolas, remember in parabolas, C was the distance from the vertex to the focus. Okay, folks, think parabola, parabola. Do you remember? I should pull that back out. Parabola. Draw you a picture. Zoom in so you can see. All right. Oh, I fear kids will forget, man. I fear I'll forget. Okay, but vertex to the focus, right, was C units. Okay, vertex to focus. It was C units. Well, we do the same thing here with this guy, folks. All right. Only it's not the vertex, it's from the center, okay, from the center of this guy to a focus. Cool, it's still C units. All right. Now, is there a relationship between A, B, and C? What do you think? Want to guess? Do you think there's a relationship between A, B, and C? Yes. Yeah, there almost always is, right? This is math, man. It's all about relationships, right? There is a relationship. Look at this. If I were to go ahead and connect a line from this point down to this focus, what would you have? All right, you have a line. Now, follow my thumb. Follow my thumb. You ready? And tracing this, what would you have?
Triangle.
I'm sorry, be more specific.
A right triangle.
A right triangle. Do we know anything about right triangles?
Yes.
B squared plus C squared would equal this guy squared, right?
Yeah.
Agreed? B squared plus C squared would equal this guy squared. That's what we know from the Pythagorean theorem. There you go. You ready? I'm going to blow you away now. Here it comes. Are you ready for it? This is A. Watch. Boom, 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 boom. How about that, folks? That's A. B squared plus C squared equals A squared. Oh, I'm so confused because the actual Pythagorean theorem is A squared plus B squared equals C squared, right? And that's not what we got here. Golly, it would have been nice if they would have just went with the Pythagorean theorem straight up and rearrange this. Real sorry about that, but you know what? We got some real simple ways that we're going to clean that up for you, okay? But it is in fact true that this distance along the minor axis, you square that, add that to the square of the distance over here to the focus, or one of the foci, all right? Take that sum, and you got the square of the distance from the center out to the vertex, which happens to be this same thing right here. Okay, so let's go check out that formula, shall we? The equation for an ellipse. Cool. Okay, actually, this is going to be way fun. This is on page 433. Before we look at that equation, I want you to see it all happen. All right, here's an ellipse. Check this out. We got foci at 5, 0, negative 5, 0, and some point out here, x, y. Okay, and now what they've done is right here is they say, all right, let's use the distance formula and the definition of an ellipse to find the equation of an ellipse. Okay, so we know that the definition tells us that the sum of these distances, all right, add up that sum, it's always the same. That sum is always the same. All right, let's see. This tells us right here, as we read through this little paragraph, the ellipse to the right has those foci. The distances from either of the x-intercepts to the foci are 2 units and 12 units. The distances from either of the x-intercepts, so here's the x-intercepts, okay, so this is 2 units, right? This is 2 units. Here's 10 units. Here's 2 units. You follow? 2, 10, 2, or shall we say 2 and 12. So therefore, if you envision bringing this all the way down here, then the sum, that sum of the distances, imagine bringing this all the way down here, then this little piece would be coming real short. It'd be right here. You want to see that on the big model? Are you following, Eli? I think Eli just spaced out. I'm having fun. Sorry, poor kid. Let's look at the big. All they're saying is they're talking about drag this thing all the way over here. Okay? Drag it all the way over here. Right? So that sum, those two distances, okay, at this particular point, when you put it all the way over here, we're talking about this length right here, which on theirs was 2, right? 2. Remember, and they went from negative 5 to positive 5. So this length was 10 between. So here's 10, and this is 2. So when we get right here, at this point, you have the short piece, which is 2, and, woo, sorry for that. And the long piece is 2 plus 10. 2 plus 10, that's 12. So 12 here and 2 here. So therefore we know the sum of the distances is what? 14, right? We can verify that easily when we come all the way over to this point, or we can go to the right side as well. But the 2 plus the 12 is 14. And so it doesn't matter where we're at on this thing, it's going to be 14, or at least for that one that's in the book, right? The sum of the distances then is 14 for the one in the book. All right, so again, when you drag it all the way over here, you'd be looking at the 2 plus the 12, 14, okay? Okay, so they're saying, all right, let's go ahead and let's read the rest of the paragraph. Sum of the distance then is 14. That dotted line is 14, and it's always going to be 14. So you can then use the distance formula and the definition of ellipse to find an equation for this particular ellipse. So check it out. It's all right. Let's go ahead and look at the distance from any point x, y to the first foci. All right. So they're looking. All right. This distance here to here. Let's look at that distance, and we can do that using the distance formula, and we'll add that to this distance. All right. So xy to the 5, 0. Right, which we know that sum then has to be 14. Agreed? Yeah. This is so cool. And then you can look at the math and you see this way cool stuff, and it's just awesome. Okay, so they use the distance form. So we don't want to waste too much time here. I just want to show you how it all kind of evolved, if you will. Ooh, the evil evolution word. Microevolution is true, folks. Just get over it. Microevolution is fine. All right, so distance form, boom, that puts you here and here, okay? Would you like to review how that goes? Oh, x minus a negative 5, x plus 5, all right, quantity squared. Y minus 0, y squared, okay? And then they say, okay, let's go and isolate the radicals. So they moved this one over to the other side. They subtracted it, puts us right here. Okay. Then we went ahead and they squared each side. So squaring this side, that removes the square root. When you square this side, you're going to be squaring a binomial, if you will. So you get the 14 squared, that gives you the 196. And you square this guy. When you square this guy, the negative becomes positive, and it removes that radical that was there. And then it's this times this and double it, right? This times this and double it, which puts us here. Okay? A negative 28 of those. All right? Once we've got that, then it's cleanup time. So they come in here, they clean this up a little bit, they square this guy. That's so great. Love this. Let me zoom in maybe a little more, maybe you can see it better. Okay, so they square this guy. Boom, boom. There that is. And then over here on this side, they did the same thing. They clean this guy up. X minus 5 quantity squared. There that is. All right. Simplify further. So then they could go ahead and knock these x squareds off. This one cancels with this one. Let's see, what else we got? This 10x and this negative 10x, slide this one over here, gives them the 20x. A negative 196, that was popping this guy to the left. Let's see, what else they got? They've got y squareds canceling out, 25s canceling out. Okay, so they cleaned it up, and now they've isolated another radical, which means now they can go ahead and divide both sides by the 4, first of all, just to get the number smaller. So they popped off a 4. Okay, so you can see that. Divide 4, divide 4, divide 4. And then they'll go ahead and square both sides again. So square it. Alright, so this guy squared. Again, squaring a binomial. Square it, square root. I'm sorry. Square it, square it. And this times this and double it. Lands you right there. On this side, you square that guy. So a negative 7 squared turns to the 49. And they remove the radical off of this because you got squared. Square and square root cancel each out. Put you here. Put you right here. Okay, then that has to be distributed. Put you there. They clean up a little bit further, and here's cool. I'm just fast forward. Clean up a little further, and that lands you right here. Boom. Here's the equation. They did divide both sides. They divide everything by a negative 1176. Put the negative 1176 here, negative 1176 here. Okay, dividing it out, so this thing is equal to 1. And there's your equation for this particular ellipse. Whoa. Wow. That's really neat. And this is what the equations for ellipses, generally speaking, this is what they kind of sort of look like. Okay? And these numbers right here, yeah, these, your A and your B, they're staring you in the face. The A and the B are super helpful because they help you with the major axis and the minor axis, right? Just remember this. A comes before B in the alphabet. A is along your major axis. A is going to be your bigger number. This guy right here is A squared. That's A squared, so therefore A is 7. And I can show you that in the picture, that is in fact the case. From here out to here is 7. From here out to here is 7. Okay, that A value was 7. Alright, the B value then, from here to here, well, again, that's buried right there. This is B squared. Okay, so here's your A squared, here's your B squared. Cool stuff. Let's go and take some notes on it. You should get one of these from your administrator, folks. Section 8.4. Helping you out a little bit with your notes. Makes it real easy. Take some good notes. You'll want to refer back to this to get this job done. Okay? Okay. So, there's actually two different types of ellipses. And one type is called horizontal. Another type is vertical. Hopefully it's obvious as to why they called them each that way. Think of it as like a football. Kind of like a football. But here that football's standing up vertically. Okay? Here it's laying on the ground horizontally. Alright? So the major axis is right here. This is your major axis. Over here, is that the major axis?
Minor.
No way. That's the minor axis. That's the short one. Okay, so that's the minor axis. All right, and this right here, that's the major axis. Major, and this one's the minor. Okay, fill in some notes. Again, everything as I showed you on that that board there earlier, right? Your A value is the distance from the center out along the edge to a vertex along your major axis. Okay, so there's your A value, there's your B value, and again the C is the distance from the center to the focus. Okay, so same thing over here. From here to here is what? A, B, or C?
That's A.
Good job, that's A. This distance from the center to a focus is?
C.
Good. And the distance along this way is?
B.
Is B. Okay. All right, great. So, the equations. Here you go. You ready? For horizontal and vertical ellipses. Horizontal one, very simple. It's x minus h quantity squared, y minus k quantity squared. What do you think hk stands for?
The vertex. No, the center.
Genius. Just like with the circle, right? Center is at hk. Alright? So for your...
But that looks like the same thing as a circle.
Yeah, we're not done. We're not done. We're not done. And notice that this is equal to 1, not r squared, right? With your vertical ellipses, look at this. Boy, that's radically different there. That's really, really different. Yeah, whoa. Okay. No, notice it's all the same stuff. Everything's the same. All right, you ready for what's different? Okay. So again, this is also equal to 1.
Oh.
This one's equal to 1. Okay. So how are they different? Well, again, I showed you that horizontal ellipse earlier. I said a is buried down here. This is a squared. And this one is b squared. Remember, a is always the bigger number. The bigger number here is associated with x, which your major axis runs in parallel with the x-axis. Left-right movement on your major axis. Okay, the bigger number is associated with left-right movement. Okay, the bigger number is always a. Over here, your bigger number a is associated with the y. It's associated with up-down movement. Where do you think the a squared should go? Here or over here?
There.
Right there, man. That's where the a squared goes. Okay? So it's really easy to remember. If your bigger number is sitting underneath the y, just know that you're dealing with a vertical ellipse. You're going to move that larger number along the y-axis. Okay? The smaller number then moving along the x-axis. All right, so these numbers are associated with the axis or the movement that you're working with. All right, so you're going to be this number, the square root of this number. That's the amount of left-right movement you got from the center. And this number, where you're sitting underneath y, the square root of that guy is always going to tell you how much you're moving in the up-down direction. Okay, so that's how you tell the difference, just by looking at the equations. All right. All right, things to remember. Remember, a squared is always the bigger one, so a squared is going to be bigger than the b squared. Okay, always true. Major axis. Okay, more on these notes. The major axis is going to go right through the foci. Okay, and the length of that major axis is easy. Remember, major axis, this is a. This is a. What's the length of the major axis? Darn tootin', 2a. You got it. The minor axis is always going to be perpendicular to the major axis. Okay, they're perpendicular. And the length of the minor axis, yeah, is 2b. The foci are how many units from the center? Oh, that was c. Remember? C units. Foci are c units from the center. Okay. So c units from the center. And we have an equation. What we did earlier, we showed you on the thing, is we showed you that b squared plus c squared equals a squared, right? Is that what I showed you on the cardboard? We're like, well, it's all messed up. It's so almost like the Pythagorean theorem. Well, all we're going to do is, the Pythagorean theorem has c squared by itself, doesn't it?
B squared, so a squared minus b squared.
Bingo. So the formula that you're going to have memorized. Just remember, it's just like the Pythagorean. It looks just like the Pythagorean theorem. A squared plus b squared equals c squared. Except instead of going plus, it's minus. Okay. We verified this earlier. You saw me do it. It was weird. Like, why? Why did I get all the letters mixed up? But again, this has everything to do with these connections on the horizontal and vertical ellipses. Okay. It's just what it has to be. All right, is this that big a deal for me to remember that it's like the Pythagorean theorem? It's just, instead of being plus, it's minus. I don't think that's that big a deal, okay? Okay, so let's go ahead and run through a quick example. Example 1. Here's what we're trying to do, is we give you an equation, and what we're trying to come up with is, all right, can you locate the center? Can you tell me whether it's horizontal or vertical ellipse? Can you tell me the length of the major and minor axis? Can you tell me where the foci are at? Okay, so find the center, foci, length of the major and minor axis. First of all, is this a horizontal or vertical ellipse?
That is a
bigger number is underneath the x.
Yes.
So therefore,
Horizontal.
that's going to be a horizontal ellipse. Okay? Remember, picture's worth 1,000 words. Go ahead and slam down that center. Okay? So I'm going to make a note of that center. Center is at, bingo, it's right here, 3, 1. Center's at 3, 1. Okay? So we're going to go ahead and plot that real quick. 1, 2, 3, 3, 1. There's my center. Okay? And now I can move how many units left, right?
5.
Thank you for not saying 25. This is a squared. The a value is 5.
You're welcome.
So 1, 2, 3, 4, 5 units, and 3, 4, 5 units, and that gives you the vertices, okay, to connect, and that creates your major axis. Okay, so we know the length of the major axis is equal to 5 plus 5, or 10. All right. The minor axis, okay, we go to this number. Okay, so this tells us move up and down how many units? 3 units. Square root of 9 is 3. So I'm going to go up 1, 2, 3. Okay, and down 1, 2, 3. All right, and that's your minor axis. 3 and 3 makes 6. So minor axis has a length 6. Okay, what's left to find? I want to know. I got this guy, got those lengths. I got my center. I need to figure out what the foci is. If you need it, if you're asked for a quick sketch or a graph, well, just connect the dots, right?
Is it foci or foci?
Foci, in English, we pronounce it as a s, right? Circus cycle cent. Remember circus cycle cent from Sing, Spell, Read, and Write? C-I-C-Y-C-E, circus cycle cent. Remember that? So in English, it's with a soft C. In Latin, it's with a ch sound, right? But we are speaking English here, so we'll go with foci. Foci, or some people accept foci. Boy, that just looks terrible. Look at that guy. Terrible. All right, but if you were using a pencil, you could straighten that out. Quick sketch of it, that's fine. But we know the foci are on that major axis. They're out like here and here somewhere, right? We need to locate them exactly. Just remember, it's real simple. It's just like the Pythagorean theorem. C squared is equal to a squared minus b squared. All right? So our c squared is equal to, well, the a squared is 25 and the b squared is 9. So 25. And obviously you need to do the smaller number, take the smaller number away from the bigger number. Make sense? So c squared is equal to 16. Okay, so that means c is equal to plus or minus 4. And you could legitimately say plus or minus 4 because you can think of it as having a directional component. You know what I'm saying? Plus or minus 4. You need to go 4 to the left and then 4 to the right to get to those foci. Okay? So this from here to here is 5. So I'm just 1 shy. There's 1. And then just 1 shy over here. Agreed? So my foci are at, I have to go, this is all the way out here. Golly, this is a 3, right? So 3 plus 3 plus 4 more. 3 plus 4 is 7. 7. So 7, comma, and that was up at 1. So 7, 1. And the other guy is at 3, go back 4. So that's a negative 1. Negative 1, comma 1. You follow Mr. Elijah Stroop. Okay. There's a decent set of notes to get you started on lesson 8.4. Okay? Okay. Play it again, Sam. That's what they say. Play it again. Here we go. So, first of all, we want to make sure that this thing looks like an ellipse should look in terms of its format. Remember, the format is more along the lines of x squared.
Look like it.
Yeah, it should move more like this, right?
In that case, it's 0.
Right? Should be equal to 1. They should be equal to 1. If they're not equal to 1, you're not really in a proper format. I need this number to be 1. How do I make this equal to 1? It's easy. What you do to one side, you do to the other side. What you do to one term, you do to all terms. It's good? It's good. So now you got to equal to 1. 3 goes to 27 9 times. 9 goes to 27 3 times. It's good? Super easy. So now you got it in that format you want. It's x squared over 3 plus y squared over 9 is equal to 1. Okay? All right, so then the next challenge is, well, what sort of ellipse? Think about what sort of ellipse you're dealing with. A vertical ellipse, because the larger number is underneath the y. And where's the center of your ellipse? Boom, boom, right? Boom, boom. Where is it?
0.
Center's at 0, 0. Okay. And then we can move 3 units. 1, 2, 3. And 1, 2, 3. And that gets you to the ends of your major axis. For the minor axis, we need the square root of 3. It's about 1.7, I think. 1.7, so. So that's about in here somewhere. So as a quick sketch, I got you a quick sketch of your ellipse. Looks a little something like this. Okay. Just remember, this is your major axis right here, and your foci are on that thing somewhere. Your foci are out here and here. Okay. Okay. So here we go. We need to make a note of some stuff. So our center, we already got that, was 0, 0. The major axis, MJ axis, is 3 and 3, so 6. The minor axis was, well, we said square root of 3 and the square root of 3. What's square root of 3 plus square root of 3?
2 square root.
Yeah, root of 3 plus root of 3 is 2 roots of 3. Darn tootin'. The only thing we need now is those foci, which again has everything to do with c. We need that c value. So I just go ahead and write it down. C squared is equal to, not a squared plus b squared, but I really don't think it's going to be too hard for you to get that in your head. I don't think so. And then you just do the math, okay? Please don't do, remember, this is a squared, these are your a squared, b squared. Don't do 3 minus 9, okay? That won't work out well. That's going to put you in imaginary numbers. If you do 3 minus 9, you're going to have a negative 6. C squared equals negative 6. That's going to put you in imaginary territory. You can't go there. We need real numbers.
3.
All right, so c squared equals 9 minus 3. Boy, that's easy. C squared equals 6. All right, square root, square root. C is equal to plus or minus the square root of 6. Okay, so that's the distance from the center to your foci.
Your foci.
So your foci, what's the x-coordinate of your foci? I'm just going to throw these numbers out there because I don't know exactly what square root of 6 is, right? And I'm too lazy to pick up a calculator. What's the x-coordinate of your foci? 0. 0. And then you have to go up the root of 6 or down the root of 6. How's that suit you? So one of them is at 0 root of 6. The other one is at 0 negative root of 6.
Yeah.
That work for you?
Yeah.
Great.
Yeah.
Let's do it again. All right, now we got problems. We got real problems. This looks nothing like an ellipse. Okay? Nothing like an ellipse. Equal to 1? It's not even equal to 1. We got problems. All right. First things first, let's take these x terms and let's get those together. Okay? Y terms. We'll get those together. We'll start aligning those things together. Remember, there's that whole process of completing the square, and we complete that square, then you can have that x minus h quantity squared, right? So that's what we're going to do. We're going to go through that process. 4x squared minus 16x, right? We're going to go ahead and go through that process of completing the square. Plus, we got the y squared minus 6y. I'm going to go through that process. This negative 11 just needs to leave. You can't be a part of my party right now. Just get out of here. We want to go through the process of completing the square. All right, obviously, this is not good right here. What do we do about that?
You take it out.
Yeah, it's got to come out, so that's x squared minus 4x. Okay, so I'm just going to rewrite that. Now let's complete that square. So
Plus 4.
half of 4 is 2. 2 squared is 4. So we're going to add 4. Now just remember what you did here. What you've really added here is 16. If we've added 16 to the left, let's go add 16 to the right. You with me?
Yeah.
All right, let's complete that square. Half of that squared. Good job, 9. And if you add 9 to the left, let's add 9 to the right. Still good?
Yeah.
All right, we continue. That's 4 times. All right, go ahead and factor it. So that's x minus 2. Over here we have y minus 3. On the right, let's see, add it up. 36 is what I'm seeing. It's good?
There you go. 36.
Yes, we don't want that 36 over there. We're really close. I want it equal to 1. So divide
Oh, no, you
all
still gotta
terms.
get the last problem.
Yeah, same stuff. So 4 goes to 36 9 times. This goes to 1. All right, so now you tell me. Here's the equation. X minus 2 quantity squared. All right, here it is.
Vertical.
He says it's a vertical. Very good. Bigger numbers here. Center is where?
Is at 2, 3.
Center's at 2, 3. Make a quick sketch because a sketch can be very helpful. Help keep your brain straight. So I'm going to do a center at 2, 3. 1, 2, 1, 2, 3. You said it's vertical. All right, so moving along, moving in the up-down direction. 6 units. Boom, 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 boom. 1, 2, 3, 4, 5, 6. So on and so forth. 3, 4, 5, 6. All right. All right, so that's along the major axis. The minor axis. 2, 3. And 1, 2, 3. All right, so there's a quick sketch of our ellipse. Nothing fancy. Just keeping my brain straight. I know where everything's at. We need the major axis
12.
is 6 and 6 is 12. The minor axis,
6.
3 and 3, right? 3 plus 3. Where'd the 3 come from? And then the toughest part of the whole deal is getting those foci. So again, we need these numbers right here. You can almost do it in your head, couldn't you? C squared is equal to A squared minus the B squared. 36 minus 9. So 36 minus 9 is
7.
27, he says. Ooh, that seems kind of real nasty right there. If c squared equals 27, that means c is equal to plus or minus the root of 27. We better pick those peaches.
3 roots 3.
3 roots of 3, he says. Good job. He's got good at the peach picking. That's your c value. Okay, so therefore, you got to go up that many and then down that many to get to those foci that lie along that major axis. Okay, don't lose track of where your foci are at. They're always on the major axis. Okay, so let's go ahead and determine where those points are at. We're starting from, all right, we need the x-coordinate first. X-coordinate looks like I'm an x-coordinate of 2. Will these have x-coordinates of 2? Yeah.
Yeah.
Yeah. If this has an x-coordinate of 2, that's x-coordinate.
Vertex.
Vertex is at 2. This is going to be 2. This is going to be 2. X-coordinates are at 2. Now we think about the y-coordinates. We're starting from a y-coordinate of 3. Agreed? And then we either go up or down from that point. So I can just do this. 3. Here's the easy way to do it. 3 plus or minus 3 roots of 3. That's the easiest way to write that. Okay? So we got all that information. Center, lengths of the axes, and the foci. Okay? Alright. I'm done playing with the equations where we start with the equations. Now we're going to flip-flop the process. And we write the equations. Alright? Alright, so let's try this. Ooh, more doggy action up there.
Scary.
That dog is scary. Alright, so here we go. The major axis. Alright, it's got endpoints at 0, 5, and 0, negative 5. Ooh, stop doggy. Foci. The foci are at 0. Let's just do plus or minus 4. Save myself some time. Okay? Alright, so what you want to do? I'll tell you what I'm going to do. My brain's slow. I'm not a very quick thinker. So I'm going to make a quick sketch. Alright, so 0, 5. 1, 2, 3, 4, 5. 0, negative 5. 1, 2, 3, 4, 5. That's the major axis. And the foci are at... Whoa. That's 5, 0. Boy. Oof. It's not a tumor.
Really messed that one up.
You're just going to let me keep going, weren't you?
I was
Wow.
distracted by those dogs.
Dogs are distracting. Alright, let's try that again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There you go.
There you go.
0, 5, 0, 5, 0, negative 5. Alright, so there's the endpoints of your major axis. Spread those out too far, that's right. And then the foci, 0, 4. I'm going to put that in red. 0, 4, and 0, negative 4. Those were the foci at. So that tells me right off the bat, this is one of those vertical sort of ellipses, right? Do we know where the center is at?
Well, wouldn't be too hard to find out.
At the origin? Hello? It's centered right there at the origin, right? 0, 5, 0, negative 5. I mean, if it gets more complicated, it's a matter of finding the midpoint of this. Okay? The midpoint of those two vertices is going to put you at the center. But this one turned out kind of easy. So our center's at 0, 0. Center at 0, 0. All right. What else? What do we need to write the equation? So think back to the equations. X minus h quantity squared over a squared. Oh wait, but this is a vertical one, so a vertical one, the a squared would be over here, wouldn't it? If it's vertical, the a squared's over here. Agreed? Okay, so let's change this to
C's just
this would be b squared. Okay. Hey, slow down. All right. So this is y minus k. So what we need is all equal to 1. What we need is the hk. Got it. Do we know the a value? Yeah, we do. From the center out to a vertex along that major axis, that a value we know is 5. Okay. Do we know, so I've got the hk, I've got the a. Do I have the b?
No.
That's the only one I'm missing. All
But
right.
you do have C's.
But we know c is 4. Okay. C is equal to 4. So here we go. C squared equals a squared minus b squared. Okay. So c squared is 4. That'll be 16 then, is equal to a squared. A squared is 25. All right. And we solve for b. All right. I'm going to do a shuffle. I'm going to slide that over here to the left. 25 take away 16 is 9. All right, so it looks like the b value is 3. And actually, not that I don't actually need the 3. Actually, what I need is to put in 9 right there, right? Let's write that equation. So here we go. HK is at 0, 0, so we're just going to go x squared
over
and y squared. And this is equal to 1. All right? X minus 0, y minus 0. Quantities squared.
over 9.
So a squared and b squared. So b squared. We're going to start with the b squared. You said 9. Good. And 25. And that's it. Okay. Let's do one more of those and we're done. All right. Last one of the day. We'll call it quits. All right. What do we got to do? Where are we going to start?
Make a little picture.
Picture. Worth 1,000 words. That's a lot of words, just saying. A lot of words. See if I can plot my ordered pairs right this time. So 2, 2, and 2, negative 10. Oh boy, that's way down there. I'm going to go 3, 6, 9, 10. Way down there. Off screen. Nope, we're in there. Alright. There and there. That's the major axis. Alright. Minor axis. 0, negative 4. 0, 0, negative 4. Oh, alright, so 1, 2, 3. 0, negative 4. And 4, negative 4. 2, 3, 4, negative 4. Okay. I'm going to make a real quick sketch. Put that in there. See it. I know that I need to know A, B, and HK. I think I already know the center. How about you?
Yeah.
I think I know the center, right? The center
2,
lies at the intersection of these two guys, right? There's the center.
negative 4.
2. Yeah, this comes over 2. So this has to get to here, that's going to have to come over 2. Elijah says negative 4. Yeah, and that's where these guys were at. Their y coordinates were at negative 4. So this would have to be at a y coordinate of negative 4. Alright? So you got the 2, negative 4. And then I think the A and the B are pretty much staring us in the face, aren't they? Right? Here we're at negative 4. Here we're at negative 10. Negative 4, negative 10. No?
6.
I'm thinking 6. Sounds pretty good to me. The B value, here we're at 2, and here we're at 4. 2. Yeah, B equals 2. Golly, that might have been easier than the last one. Alright, so let's set it up. Here we go.
And C is equal
X,
to
and we don't even need the C though, right?
Yeah.
We can find it if we want, but I don't need the C. So here we go. X minus H, so X minus,
2.
good job, 2 squared. I'm going to do the A-B thing later. Let me get this right.
1
So Y,
plus 4.
okay, and that's
equal to 1.
equal to 1. And now, where's the A squared go?
Under the Y.
under the y. All right. So a squared is coming right here. That'll be 36, and this will be 4. Ta-da! Bada bing, bada bang, bada boom, bum, bum. That was cool. Ellipses, man! I highly encourage you to check out that stuff I mentioned there at the beginning of class. The principle is way cool. I've watched it once. It was kind of tough for me because I'm not very smart. But the 30-minute one that I mentioned that was on the Fatima network channel, that one is really good. 30 minutes, and it was pretty easy for me to follow, even though I'm not very smart. Kind of slow sometimes when it comes to real complicated science, but interesting stuff to think about with Copernicus and Kepler and heliocentric versus the geocentric theories. I think they make some real good, strong points, and pretty amazing. Anyways, hopefully all of the regular students tuned in for our review of homework and quizzes, but otherwise the lesson itself was for Honors Algebra 2 only. So do those odds, check them as you go. Make sure you're doing okay and feeling okay. And then tomorrow we'll look at a whole new, what's called a conic section. We've been studying conic sections. Parabolas is a conic section. Circle is a conic section. We're going to review those things from geometry, and we'll talk about that maybe tomorrow. What's conic sections? What is this all about? But tomorrow we'll look at hyperbolas, which is another conic section. All right, conic sections, good stuff. All right, folks, I had a great time. Hope you did too. God bless you all. I'll talk at you later. Bye-bye.